Hi everyone, let's solve today's daily challenge, that is determine if a cell is reachable at a given time. So in this question, you are given four integers sx, sy, fx, fy, right? So sx, sy is actually the starting cell and fx, fy is the ending cell. And another variable you are given is the integer t. You are inside of an infinite 2D grid, okay? And you are starting at the cell sx and sy. Now, each second you must move to any of its adjacent cells. Now, return true if you can reach the cell this fxfy after exactly t seconds, or false otherwise. And cells adjacent cells include the 8 cells surrounding it. Okay, and it share at least one corner with it. Okay, and you can also visit the same cell several times. Let us see what the problem is. What we are given is an infinite 2D grid, right? And okay, so you must assume it goes like this, okay? And you have a starting point. Let's call this your starting point. And let's say this is your ending point, okay? Fx comma fy. Starting cell, ending cell. Now you're given a variable t, and within exactly t seconds, you must reach from s6 sy to fx fy. All right. So now let us go ahead and try to reach here. Let's say t given to us is 10. Okay. So now what I can do is, let's say I move like this. So this is 1 second. So each move takes 1 second, right? Each second you must move to any of the adjacent cell. Now adjacent cell include, if I'm standing here, right? So adjacent cell include this one, this one, this one, this one. These are adjacent, and along with that, all the diagonal cells, right? All the diagonal cells. So all 8 directions are considered as adjacent cells, right? So these are the movements that we can make. So we are moving here. So 1 second has passed. Now, let's say we move here 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7, 8, 9, and 10. So within 10 seconds, we are able to reach fx, fy. So in this case, I have to return true, right? So that is the question. Now, how to solve this question, right? If I try to, for each and every cell, if I try to consider all kinds of direction, now I have this parameter t here, right? And I'm not calculating shortest, right? Or longest, or anything like that. I'm not doing that, right? Minimum, maximum, nothing is like that, right? Within exactly t seconds, I have to reach. So if I try to do brute force, right, that I try to explore all 8 directions of this cell, right, and from among those 8 directions, I keep moving and I try to reach this particular cell. It will be taking a lot of time complexity, right, and it will become a very complex solution as well. So that's not a feasible thing to do. Now let us try to understand what else we can do here. Now, if you see, we are saying you have to exactly reach within t seconds. And another thing is given to you that you must move to any of the adjacent cell each second, right? So you cannot stand anywhere. And also another thing here you can notice is that you can visit the same cell several times. All right. So now the intention is, if I can somehow figure out the shortest time, right? The shortest time to reach from this start cell, the finish cell, then I can say if this shortest time, right? This t is greater than or equal to this shortest time, then definitely I can reach from S6, the start cell, to the final cell, right? So I hope you get it, right? What we want to calculate is the shortest time that we require to reach this cell, right? So any time that is given more than the shortest time or equal to the shortest time, we can definitely reach the final cell, right? So that is the intuition behind this problem. Now we have figured out what we want to do. We want to calculate the shortest time, and according to that time, we have to compare it with t, and then we can easily solve this question. Now, how to figure out the shortest time? Let us see. Okay, let me draw these lines again. Okay, all right. Let me mark these as 0, 1, 2, 3, 4, 5. Let me make two more rows. 6 and 7. All right, so your starting point you can see is 0 comma 0, and this is your ending point, which is 5 comma 7. Okay, the final, which is fx f5. Now since I have to reach it in shortest time, what shall I do? So definitely I can say, if I try to reduce both the coordinates, that is, I try to move diagonally, right? If I try to move diagonally, so 1 second, 2 second, 3 second, 4 second, and 5 second, right? So within 5 seconds I was able to reach here, right? If you try to do any other way, right, you come here and then come here, right? So you can see, for each diagonal movement, if you try to traverse that distance by doing horizontal and vertical traversal, then you can see you are taking 2 seconds, but when you are doing diagonal movement, you're only taking 1 second. So I know if I can move most diagonal movements, right, then I can definitely reach within shortest time. And after this, you can definitely see, I have to move vertically down, and then I can reach my final cell. So how much time did I take? I took 7 seconds to reach to the final cell. So now what I can see is I have to make what? Diagonal movements. Up to what point? Up to whether S6 becomes equal to Fx or Sy becomes equal to Fy, right? That can also be a case. That case will arise when let's say, here what happened? Here Sy became equal, right? Sorry, it was Sx that became equal, right? So it was Sx that became equal here. Now what if my final cell lies here? Then I will traverse this particular distance diagonally, and then I will have to traverse horizontally like this, right? So then what will happen? Then my Sy and Fy will be equal, right? So these are the two conditions, right? If they become equal, then I have to stop traversing diagonally, right? Because they became equal, so there is no point in decreasing this particular coordinate, right? Or this particular coordinate. Okay, so I can say I have to keep moving like this, and I have to traverse some vertical or horizontal distance, and then I can say whatever time this particular traversal requires is the shortest time, right? We can see here also. You can also try to draw different other scenarios, and then also you'll observe that whatever distance I can travel diagonally, I have to traverse diagonally, and then I have to move either vertical or horizontal direction, right? Then there will be no more diagonal movements that I can do. So now, if I try to calculate this particular distance, how will I be able to, right, using these two coordinates? So it's easy. So basically what we are saying is, either this particular distance will be remaining Fx, or, and we'll be taking the ABS of this, okay, and remaining, or let me write here ABS of remaining Fy minus Sy distance, right? This is the remaining distance. Now, how can we know the remaining distance, right? Look, when Sx will become equal to Fy, this particular distance will become 0, or this particular distance will become 0. So I can say for C amount of time, right, I am decreasing both Sx or Sy, right? For C steps, right? I'm decreasing both of these. So I can say if I add C to this and if I add C to this, then I can definitely know the coordinates, right? That is the diagonal distance that I have traversed, right? If I add C, and what's C plus Sx and C plus Fx, correct? Similarly, C plus Fy and C plus Sy. Now, among this expression or this expression, right, one will become 0 first, right, before the other expression. So I can safely say that if I calculate the maximum out of this particular distance, that is going to be my shortest time, right? So by just calculating Sx minus Fx, right, it's ABS and ABS of Sy minus Fy, whichever is maximum, right, I can calculate my shortest time as that only, right? So the maximum of this particular time, right, is going to be my shortest time. Why? Because look, for some distance, right, I have to, for C steps, as I said, if I want to calculate what will be the remaining, right? This remaining that I am writing, this remaining is nothing but Sx minus C minus Fx minus C, because C is the constant that we are decreasing from Sx and Sy both, right? Not here, right? And the remaining for Sy will be Sy minus C minus Fy, right? This is going to be the remaining value. But the C is constant. The C is constant. So it doesn't matter if I add it or not. All I know is that my shortest time will become the maximum of the remaining times. And so because of this constant, I can safely say if I only do Sx minus Fx and if I only do Sy minus Fy, I am going to get the shortest time by getting the maximum value. Why maximum? Because these were my C steps, right? These are my C steps, that is 5. But I need 2 more steps to reach to the final cell, correct? Here also I will need 2 more steps. If the cell was here, then I would have required 4 more steps, correct? So I need these extra steps also to reach the final cell. So that is why we are taking the maximum of this value. So I hope it is clear to you. That is all we have to do, right? We have to calculate the shortest time. We have to calculate the shortest time, and whatever is the t value that is given to us, if this value is greater than or equal to the shortest time, then I can safely say that I will be able to reach that final cell in exactly t seconds, right? So I hope that is clear to you. Now, there is one condition that we missed, right? That one corner case. What is the corner case? The corner case is, let's say you are standing at this cell and you are saying, I want to travel to this cell only. So that is your Sx, Sy and Fx, Fy are both equal, right? They both are equal. So you have to travel to this cell only. So in what case is it not possible to travel to this cell, right? If you take any value of t, right, you will be able to come here, right? You can go like this, that, and come here. But for one value of t, you will not be able to. Why? Because if t is given to be 1, okay, if t is 1, then you will be able to go here. But how will you be able to come back? You will not be able to come back, right? So for this particular, this is a corner case, right? Edge case, that if t is 1, you will not be able to come back to this cell. Otherwise, you take any value, t greater than 1, any value will make you reach to this cell, right? So if it is 2, then you can go like this and then come back like this. If it is 3, then go like this, right? 2 and 3, you're coming back. If it is 4, right? So you can see, for every value t greater than 1, you will be able to reach this cell, but you will not be able to reach this cell if t is equal to 1. So this is the corner case in for this particular question, right? Otherwise, for all other cases, you have to calculate the shortest time, and then you have to simply calculate this particular value, that is maximum of abs of Sx minus Fx and abs of Sy minus Fy, right? So let us quickly code it. So let us first write the edge case, right? That is, if Fx equal Sx and Fy is equal Sy, right? then what will happen? We have to check. T must not be 1 in this condition. If it is 1, then simply return false, right? Otherwise, whatever be the value of t must be greater than 1 only. And it is a non-negative integer, right? So we don't have to check anything else. Greater than 1, if t is greater than 1, then definitely we will be reaching that cell again. Now, otherwise, we have to calculate a value, right? That is minimum time or shortest time value. So minimum time is going to be what? It is going to be maximum of, as we saw, abs of s6 minus fx comma abs of sy minus fy. So this is going to be my shortest time, that is minimum time required. And then I will simply check it against the t that is given to me, right? If it is less than equal to t, this minimum time is less than equal to t, then definitely we will be reaching that set. So we'll say return true here, otherwise return false. So that's all we have to do. So let's quickly run it. So you can see it is accepted. So that is basically how we have to solve this question.